All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Have you encountered any situation in which you are calling to somebody on a phone and receiving your voice back again? This happens because of impedance mismatching. Why some signal which has been sent by you to somebody comes back to you again? Hello everyone, I am Sachin Kumar. Welcome to S.chand Academy. Today in this lecture we are going to study about the reflection and transmission of a wave. And at the end of this lecture we will come to know about this, that why some signals come back and what is overall impedance mismatching. To read about this topic in full detail, you can refer this book by S.chand Publishing, and you can also find its ebook link in the description box. Now let's start our lecture. Overall, we are discussing about the motion of a transverse wave in a string, in which we can imagine that I have a string from minus infinity to plus infinity. So I have a string from minus infinity to plus infinity. But there is a difference between them. From minus infinity to 0, I have one string whose I can say the mass per unit length is mu1, and the other part from x to infinity plus infinity, so it is a different kind of string, or maybe you can say it is a thicker string. We are just assuming that. We can also assume that this is a thinner wire, so that will also work with mass per unit length quantity as mu2. Overall, x is equal to 0 is the point from where, if some wave is coming from negative of infinity towards 0, then at this point what will happen, this is what we want to know. Let us just imagine that a wave of any pattern is coming towards this point x equal to 0, and we can just imagine that this is f function I am writing for incidence. So this is a incidence pulse x minus ct. So the general wave pattern which is moving in time, whose velocity is c, that can be written as x minus ct. And I can also modify this for the simplification in this expression. I can write this as fi t minus x by c. So this is just a representation in which now it is a function of t, and minus x by c we have represented it like this. Overall, this is easy to understand for this expression, in which we are just studying about the time and the velocity of this wave. Now let us consider at this part of the string from minus infinity to x equal to 0, the velocity of this wave is c1. So overall, the function which is defining the incident wave is t minus x divided by c1. Yes, and when it comes to this point x equal to 0, either the signal will be transmitted to the second string, or some signal may reflect to the first string back again. So in that condition we can write that so one function which is defined as this is transmitted function. So function which is explaining the transmitted wave, is equal to t minus x by c2. So the direction of motion is the same towards the right. So that's why I am not changing its sign, it is minus again. But because the medium has changed, the velocity c2 will be applicable. Some part of the wave may reflect as well depending on the nature of the strings. So I can also write this f, which is reflected ref, t minus, instead of minus now I am changing to plus, x by c1. So overall we have defined three functions, fi, f transmitted and f reflected. Now what do we want to understand out of this topic? Basically one wave is coming whose function is fi, and we are imagining like, okay, same kind of function is transmitting and same kind of function is reflecting back. Overall something is transmitting and something is reflecting. So the transmitting wave is f trans and the reflected wave is f reflect. So this is the overall picture. But what overall we want from this expression? We have the incident wave and we want to explain the reflected and the transmitted wave in terms of the incident wave. Overall, just because we know about the incident wave, if we get the expression in its term, then we know the transmitted and reflected parts. So that's very easy. Now we can look at it in a certain way, like overall the function towards the left side. What is the function towards the left side? Left side of what? Left side of x is equal to 0. Here we can say that, okay, this incident wave, which is t minus x by c1, and plus this reflected wave, both are towards the left part of this x equal to 0. So this reflected part can be written as t plus x by c1. Fine. And what is towards the right side of this x equal to 0? If we look at towards the right side, only reflected wave has moved towards the right side. So the overall function towards the right side is this function which has been transmitted. So as trans I am writing this bracketed t minus x by c2. Yes, this is the function, but the main task is still pending. We want to overall express this function of reflected and transmitted waves in terms of incident wave. So what should we do at this point? Overall, we have some boundary conditions. Boundary conditions at x equal to 0. We can think of that like x equal to 0, both strings are connected to each other. So you can't say like if one end is here, another end will be there. We know that both ends should be at one place. First thing. And the second thing is that if it is continuous string, in that case their slopes should also be continuous. Then on applying these conditions, we should get an appropriate result out of it. So basically, after a short break, we will come to this point and discuss it.
हाय, आई एम मनीषा सिंगला। इनऑर्गेनिक और ऑर्गेनिक के कुछ डिफ़िकल्ट कॉन्सेप्ट्स को आसानी से समझाने के लिए मैं आ रही हूँ S.chand अकेडमी में। तो अगर आप हमारे वीडियोस को देखना चाहते हैं तो सब्सक्राइब ज़रूर कीजिए।
Welcome back to S.chand Academy. Before going to break, we were discussing about the motion of a wave in a string when there is a different string at one part and different string another part. So what sort of reflection or transmission of waves we observe in this? We have gathered the knowledge about the overall waves in left and right part. Now we are going to apply some boundary conditions here. So I said you like it is one string overall attached at x equal to 0. So in that case I can say that this overall wave function towards the left side and overall wave function towards the right side should be equal to each other at point x equal to 0 at any time t, just because the string is connected. So this is the one boundary condition which we should apply. So what should we get out of it? Towards left side we have incident wave and the reflected wave. So overall we will get incident, and we also put the x equal to 0. So overall it will become the function of t only. So f incident t plus f reflected, and it is also a function of t because x is now 0. And in case towards right side of x equal to 0 point, we can say that okay, the function which is explaining transmitted wave, and this is also a function of t, is equal to this. So overall this is one equation we are getting from this boundary condition. Now the next point, we can imagine that because this is continuous, this string is continuous, their slope at x equal to 0 should also be continuous. So let's write it like this. So the function towards left hand side, its derivative with respect to x, and initially it is a function of x and t, but after that you will put x is equal to 0, and this is equal to the derivative of function towards right hand side with respect to x. Initially it is a function of x and t, but after that you will put x is equal to 0. Yes, so you are going to apply this, and what you are going to get out of it? So finally if we differentiate this left part and put x is equal to 0 at this place, we will get minus 1 by c1 f dash incidence, and this is a function of t only because now x is equal to 0. After that plus 1 by c1 the derivative of this function which is representing the reflected part, and now this is also a function of t only because x is equal to 0. Finally towards right hand side if I differentiate this, so then I get minus 1 by c2 into the derivative of the function which is explaining the transmitted part, and as a function of t. So overall I am getting this expression. I can simplify this and can multiply c2 at this side, c1 towards right hand side, and finally we will get this as c2 derivative of f incident wave, and then negative of c2 derivative of reflected part t is equal to c1 derivative of transmitted part t. So this is the way in which we are simplifying these equations. Finally if I integrate both sides, then the basic pattern I will get. So the c2 incident time minus c2 f reflected as a function of t is equal to c1 the function for transmitted and t. Now guys, we have two equations. So one is this and another is this one, explaining the relation between the incident reflected and transmitted wave. We can eliminate the reflected and transmitted one by one and can get an expression. If we first eliminate the transmitted part, so overall the reflected part I will get out of this is T is equal to C2 minus C1 divided by C2 plus C1, and the second part is the incident wave. So here T is a time variable, but generally this expression is valid for any variable like this. Overall, this equation can be written as, so if I have an incident wave phi like this in the direction x and t, and if I reverse this direction, so minus x I am putting at this place is equal to C2 minus C1 divided by C2 plus C1. So it is explaining the reflected wave, which is phi reflected, which is a function of x and t. I can also mention the incident part here. So in this way, this expression can be understood like if you have some incident wave, you will get some reflected part, and that totally depends upon the velocity of those waves in those strings. Similarly, we can also eliminate the reflected part and get an expression for the transmitted part. So in case of that, phi transmitted part, which is a function of x and t, will be equal to 2c2 divided by c2 plus c1 into this function phi incident. This is in terms of x and t, but the velocity, their velocities are different. So overall I am multiplying this number v1 by v2 with this as well, because if in the incident wave I multiply x with this value v1 by v2, only then this will explain this function which is of transmitted wave. Overall, the ratio of the velocities when you leave one medium and enter another medium is also the origin of refractive index, in which the refractive index is the ratio of their velocities. So in the same way, the ratio of the velocities is explaining it when from one medium you are traveling to another medium. In telecommunication industry, they take care that when a signal is going to a circuit, so the impedance means you can imagine like resistance. Okay, so some kind of resistance. The resistance in both part of the systems, the receiver and the acceptor should be approximately the same. If they are close, in that case only the total signal will pass. If there is a mismatching, or if I can say that if their resistances are not the same, in that case a wave will reflect and come back, and you will hear your voice again in your phone. So overall, this impedance mismatching causes this, and this is the mechanical equivalent of that problem. Overall, as a summary, if we look at this lecture, we started with a discussion that we have two mediums, one dimensional mediums, like two strings, one from minus infinity to 0 and another from 0 to infinity. Their linear mass densities are different. So we are expecting some kind of reflection and transmission as well. We started with a wave function of an incident wave, then reflected and transmitted. We just corrected their directions of motion, their velocities, and finally we came to a point where we applied some boundary conditions at x equal to 0. After applying those boundary conditions, we found that our wave function which is the reflected part, and the transmitted part, both can be explained in the terms of incident wave. In this case, our mediums are linear, but whenever a wave transmits from one medium to another medium, in that case there is an origin of refractive index, and that quantity V1 by V2 was introduced just because of that. To read about this topic in full detail, you can refer this book by S.chand Publishing, and you can also find its ebook link in the description box. Please don't forget to like, share and subscribe to this video.